In this video, we're going to look at C++, and in C++, we're going to look at the if statement, if else, and then the switch. An if statement is a fundamental construct that facilitates decision making in programming. It allows the program to execute specific code blocks based on the evaluation of conditions, enabling dynamic behavior and flexibility in the execution flow of the program. So how do we get to start this? We get to the search box and then type in, we're going to use dev, but you can also use Bolan C++. So when we start dev, we type in our code. So when dev opens, we go to the toolbar here, we click the new icon, which you can still get from the file. So when you start the code, now there we'll start typing our code. So remember so that the if statement is accompanied sometimes by the else, where the else gives us the condition to take another decision. But let's start with the if. We start, remember, our C program, we start with the hash include, then the IO string, yes. Then from there, we can go to using namespace, then std. This one, it enables us to use the cout, to use the cin each time we want to use it without using the term the std and then the full two double full colon each time we need to use the cout. So this one just declare it once and then we continue using it. So we have opened up our main function. Now what is remaining is for us to do some statements or some coding. So let's start by declaring int num. This is just a short for number, but you can declare any variable. Let's start with 6, and then we are going to write our if function. So we say that if for example, that number that we have entered, if it is greater than 5, then a condition should be executed. And this one will open a block. Remember, block is put in curly braces. So we open if num is greater than 5, then we write block of statements which are to be executed. So we are going to say that if num is greater than 5, then you should output that the number is greater than the number is greater than 5. Okay. Then of course we terminate our condition. That will be the condition. It will test if the number is greater than 5, then it will output that statement on the console. But we have to first save. This is our if statement. We save the file as if statement. Then after saving, or remember sometimes you can save it as a .cpp, but it is okay. We can save it without putting an extension. Dev will put it for us by default. So when you're done, you compile the file, and of course, if the compilation is okay, there is no error, it will return the time of compilation. Otherwise, it will return the error. Then we run the program. Yes, the number is greater than 5. You see how we typed greater than. Yes, it was supposed to be greater. It's a correct English statement, greater than 5. But what if the number is not greater than 5? Supposing we enter a number which is 1. What will happen? Let's save. We can compile and run at the same time. The program returns nothing because all what you instructed the code is to execute that the number is greater than 5 if the number is greater than 5. But you didn't say what happens when the number is not greater than 5. Like for this case, the number is not greater than 5. But then sometimes we can say maybe to execute a statement always outside the if function. Okay. Can say there, see out, I am outside the if block. That statement will always be executed irrespective of what condition has been met here because the condition, its scope starts from here up to here. Yes, let's see what happens. Mhm. Oh, sorry. It says expected this, expected a semicolon before this token. Yes, we did not terminate this. We were supposed to terminate that like that. Yes. Then save, compile, and run. Good. I am outside the if block. Good. Okay. Let's say again, let's see what happens. What if we are not outside? What if the condition is still met? What will happen? The number is equal to 10. It says the number is greater than 5. I am outside the if block. Now you see how this statement has been combined onto this one or concatenated. Eh? So in order to avoid this statement to come together with this one, just after here, we can introduce end of the line. We can introduce a new line such that after printing this, go to a new line, then do whatever you're supposed to be doing. Yes. The number is greater than 5. I am outside the if block. But still, now at that condition, that is only using if. But you can say if this is true, print this. Else, do another execution. So if number is greater than 5, see out the number is greater than 5. Then you can say else, and say else. Now we are using the if else statement. So we have it will be executing when the condition is outside. Yes, so we're saying that else, so that is it is put outside. Even the else, it is also executed as a code block. So we can say else, see out. Mhm. The number is less than 5. Yes. Then, yeah, let's get a new line. Then terminate. Okay. Let's first ignore this other statement which is executed irrespective of what condition. Let me comment it out so that the program does not read it. Run and compile. The number is greater than 5. Why? Because the number is 10. But what if it is a, oh, it is an integer, you can't supply it as 1.0. What if it is just 1? Or any other number, not necessarily 1. It can be 3. What happens? The number is less than 5. So what happens here is that it tests, is the number greater than 5? No, it skips out of this block. Then it goes to the next statement. It says else print the number is less than 5. So for this case, yes, indeed it's 3. The number is less than 5. That is the if statement. It is this statement you can even put equal to. Okay, if the number is equal to 5, then you can say the number is equal to, the number is equal to, not always 5, it can be 3. It will be test, is the number equal to 3? The number is equal to 3. Else, it will say the number is not 3. The number, remember these are just your words, but they must match, they must, because if it is not equal to 3, it will simply say the number is less than 5, because that is what you have provided exactly the computer. Remember, a computer is garbage in, garbage out. It is you to give the computer the correct statements in order for it to execute the correct statement. So let's put the correct statement. The number is not equal to 3. Save. The number is equal to 3 because 3 is not is equal to 3. But if you initiate 3 as equal to any other number other than 3, what happens? Remember, each time we save and then we compile and run. Yes, the number is not equal to 3. Now the next statement is executed. But what happens if we uncomment this one out? If you uncomment this one out, this statement will be executed irrespective of what condition. The number is not equal to 3. I am out of the if block. And remember the other number is 10. Even if we put, okay, let me put 3 here, still the number is equal to 3. Save, compile, and run. The number is equal to 3. I am outside the if block. So that statement that you put outside the if else, it is always executed irrespective of the condition that you find there. Yes, so that is, so the if-else statement are conditional statements that allow your program to make decisions based on certain conditions. They control the flow execution by selectively executing different blocks of code based on whether the condition is true or it is false. So that is what we have just seen. Now, again, there is what we call the nested if-else statements. We can have an if statement nested within another statement. We have the if statement, and then inside we have another statement which is nested. If still inside another if. So let's say, for example, here we say int num, a number. It's not always that it's supposed to be num. It can be x. If x is equal to, let me use another value. Maybe if x is equal to 12, comma, sorry, int x equals 12. That is our declaration. We have declared a variable x of type integer, and we have initialized it to 12, or we have stored there a value which is 12. And now here we are testing that if x is greater or equal to 10, that is our condition. What happens? See out the number is greater than, not equal to. The number is greater than 10. We don't want this other statement. Yes, the number is greater than 10. That is the first if statement. Um, Then we can also have another if. We can have another if, and then we can say immediately after that statement, it starts from there and ends there. Then we can say if x is greater than 5, what will happen? Again, we can say if the number is greater than 5, let's get this one out from here. Got it. We can put a block there and then decide to put it there. The number is greater than 10. The number is greater than 10. Then from there we can say else the number is, so it is first test if x is greater than 10. It outputs the number is greater than 10 and it ends. Then from there we say that if x is greater than 5, we can decide not to output anything, but still it can work. Then from there we say else, see out the number is not equal to 10. Yes, the number is greater than 10 because the number you have supplied was greater than 10. Yes, 12 is greater than 10. So that is the nested if else statement. So a nested if statement. But then we can go ahead and have more other multiple conditions. We can have multiple conditions. Let's use still the same whatever. You say hash include IOStream using namespace std into main. These statements must always be there in the program because this main is the one that executes all other functions. So it calls other functions. So if you don't have the main function there, your program will not be executed. It will not run because there will be no program calling it. So you have to, let's have declare some variable y and then of type integer, and then you store there some value like 8. Then after that we can write another if statement. If that value y is equal to, remember equal to we use double. If it is equal to 0, what should the program do? If it is equal to 0, yes, you can say see out, say the number is 0. It's always good practice to go on a new line after doing whatever you're doing. The number is 0. Else, now, sorry, we have to get out of this block of if. Because whatever you put here, if you put here another statement, it will still be executed whenever y is equal to 0. Then we say else, that is if, else if, that is now a new term. So we are using multiple statements, more than one statement. We started with if y is equal to this, we print the number is 0. Else if, we are going to put another condition again. Else if y is greater than 0, yes, then you open a block. What should the code do? See out, see out that the number is positive. Yes, that is a program that checks whether a number is greater than 0 or it is positive. The number is positive. New line. So the number is positive. Now, what if the number is not positive? Any number which is not positive, it must be negative. So we get out of the else block. You see it starts from here up here. That is the scope. Enter. Now we say else. They shall give it to block. See out. The number is negative. The number is negative. Yes. Still, let's get a new line there. Terminate. So that is the if else statement. So we start with if the number is equal to 0, we say the number is 0. So there we are not taking 0 as positive or negative. We are just taking 0 as a boundary between negative numbers and positive numbers. And then we say else if the number is greater than 0, that is when you say the number is positive. Else the number is negative. Already this program was saved. We just Control S and then we compile. To compile and run at the same time, you just hit the F11 button. Say the number is positive. That's true. The number is positive. But again, there is also a situation when you enter the number may be, let's say you enter negative 8. Save F11. The number is negative. Okay. What if you enter the number as 0? Control S, hit F11. The number is 0. That is the multiple if statement. So we start with the if, then if you want another condition, say else if, then else if, then else if. The last one is the else statement. Okay. Remember here we have, yes, we have started with y, but you can just declare y. After declaring y, now we want a user to enter y via the keyboard. So we start by instructing the user, enter the value of y. There we are just instructing the user to enter that value, comma. Now this one, see in, we are allowing the user to enter that value. The value is y. Then you terminate. This is what is going to see, and this is the one which is going to allow the user to enter the text via the keyboard, which text is going to be y. Enter the value of y. So I'm entering 90. The number is positive. But again, you can say, I don't want to say the number is positive. Instead of saying the number is positive, you can say, you can start here with picking that actual value from the keyboard. Okay. And then you say that, just not like that. That this one is 0. Which one? This very number that has been picked from the keyboard is 0. We can again go down here. Instead of say the number is positive, let's just pick the actual number. Then you say is positive. Instead of saying that the number is negative, let us pick the actual number, which is y, and then we say that it is that y is negative. We can modify our code like that. Compile and run. See out. Oh, what? Oh, this was a single less than symbol. Okay, there is an error there. Enter the value of y. I can enter it as negative 90. Continue. Negative 90 is negative. Though it is a bit funny. Run again. I'm going to enter 78. 78 is positive. Run again. I'm going to enter 0. 0 is 0. Okay. That is how we can display the value that you have entered via the keyboard on the screen. So that is when we want multiple conditions. Again, multiple conditions can be like maybe you are interested in grading student. There again, you have multiple conditions. Okay. When you're going to grade the student, let me remain with the first, yes, up to there, because a code must start with this. Now, we want to see again multiple conditions. We want to enter student score to grade. So we start by getting a student score. We declare it. And then we also declare a grade is given as A or B or C or D. So that one is just a single character. So we declare a character, which is that means we have declared a variable called grade, and this grade is going to be of type character. This statement is the same as even when you just put two of them on separate line, because C ignores white spaces. And the same spirit, even this one, I can just put it there like that. That statement is the same. Even here, I can just put that one there, such that all the statements I'm going to write are going to be in a single line. But of course, that line is going to be too long and abnormal. Going through it, readability is not going to be easy. That's why you enter and then you put on different lines. Okay. So I have declared a variable score and a variable grade. Score is of type integer. It's going to store a whole number. And then score, then grade is going to capture single letters, single symbols. Now, this time we want a user to enter this score via the keyboard. So we instruct a user to enter the score. Instruct a user to enter the score. Then after that, you allow the user to enter that score and you pick. Remember that is it. This is score. Each time you terminate. That is a program where if you compile and run, it is going to allow you to enter the score, but it will do nothing. Please enter the student score. Student has scored 78. That is it. You have entered the score, it has been stored in the score. But you have told the computer to do nothing and it is not going to have. Now, next, we are going to check the score which has been entered. For example, that 78 which was entered. What can we do? We say if uh, uh, if what? If score is greater or equal to 90, what should be done? In the brace, yes, I want them on the same line. See out, the grade is, no. We are not going to output. Sorry, we are not going to output. We are just going to allocate grade. We are just going to allocate grade. We are going to assign grade a value. If the score is 90, then assign the grade a value, which is capital A. That is if the score is 90. Then the program can go ahead and say, if it is not 90, you say, else if the score is greater than 80, what should be done? Copy that. Then allocate the grade to B. The grade should be B. If it is not, then we say else if, yes, the score is greater or equal to, now allow me to equal to certain value, then allow me to get something like that, so that all the time I will be just copying. See, when you're typing, you have to be fast. Now, even here, let me put grade still. Grade is, so I'll be using this statement. Yes, so we say if score is greater or equal to 70, the grade should be C. Option C. Yeah, the grade should be C. Then, else if the score is greater or equal to 70, the grade should be D. Else if the score is greater or equal to 50, the grade should be for A, B, C, D, E. Else if the score is greater or equal to 40, the grade should be O. I think, that is the last grade. Now you can say else. This is the one which should be executed all the time. Okay. So that else, even else is also put in the block. It's also block. Else, um, the score, so we need to score. Else grade is F. Else grade is F. So it will keep on testing through. So any other marker which is not indicated here, which is less than 40 or not equal to 40, its grade is going to be F. You save, then compile and run. We made a mistake somewhere. If grade, if score is greater or equal to 90, grade is A. Yes. We are supposed to terminate these conditions. I didn't terminate. For it to become a statement, it has to be terminated. It has to be terminated. Even here to say expected semicolon before that token, this one. Yes, so even here, these are statements. A statement is the how you get to know that this is a statement, you must put there a semicolon to terminate. Yes, save, hit F11. Please enter the student score. The student scored 35. Press any key to continue. It has done nothing. Yes. Why? Because you allocated the grade is there, but you did not instruct it to output. So now, after outside the else, this statement will always be executed. Then we say C out the grade, or we can even just decide to pick the mark. The grade 4, now pick score. Is, yes. Now we return the grade. End line, sorry, just return the grade, then terminate. Control S, hit F11. Please enter the student score. The student scored 56. The grade for 56 is E. Now you can see for 56 and E's, they are too close. Why? Because you didn't put a space there. Just put a space there such that things are not congested. Together, Control S, hit F11. The student scored 35. The grade for 35 is F. See that? That is how we use multiple if-else statements. Okay. Running the shortcut is F10. If you can continue running your program. But if you enter negative 45, the score is still what? F. So that is what you do, okay, for different conditions or different marks. So that is the if-else statement. That is how it works. It is the same as when you have still multiple if-else statements. Multiple if-else statements can be done like that. Now we are going to look at the switch statement. In case you don't want to deal with the if, you can use the switch. It offers concise way to evaluate variables against multiple cases. They provide an efficient and readable alternative to multiple if-else statements. And when applied to grading, for example, such statements can simplify the code and make it maintainable. So we start by declaring the score, student score. Then we instruct the student to someone to enter student score in this statement. Then this statement here, following statement, it is allowing the user to enter marks via the keyboard. Then we declare the student's grade. Then after that, now we start the switch. The switch statement, it is formatted like that. With inside the parentheses, we put what is to be evaluated. So we put there the score, then we divide it by 10 such that it can be able to determine the range of marks. For example, when you enter somebody gets 100%, that will be able to get a case. So we are going to use cases from case 10. So say in case 10, yes, and then let us combine it together with the case 9. Case 9. This means that whoever enters the marks, somebody gets maybe 90, that 90 will be divided by 10, that will be case 9. And then after that, you can get the grade. So that one can be assigned the grade of A. Then you terminate. So you get that, you'll be assigned the grade of A. Any mark, 9, 95, 96, 98, those values are evaluated to integer values, so they come back to 90. Or 100, it will still get the, sorry, this is an error. The full colon is put here. Then we have another case. Maybe we can have case 8. The grade should be a B. Then we break. Every after a case, we have got to supply the break statement, meaning that if it is not evaluated to that, we jump out of that break statement. So in case it is not any of this, we jump out of that, and then so the, the break is supposed to be at the end of the case there. In case the grade is not A, you jump out and then case 8 is tested. Any marker you enter between 80 to less than 90 will be given a grade of B. Then we can have another case. Let me copy this. Then be editing. You can have another case, for example, case 7, anybody who gets in 70s, then the grade is going to be C. Then you break, get out of that, then test another condition, maybe case 6, anybody who gets 60, the grade is going to be a D. The grade is going to be a D. If it is not a D, we break out of that case. Then we get another case, possibly case 5. If it is not D, then that is going to be E. So anybody who gets marks within 50s will get the grade of B. We can stop there. We can stop there, and then now we can make the default value. If you don't put a default value, then nothing will happen. But let's say default for any other mark which is not within 50s, it is going to give the grade of F. It's going to assign grade of F. Yes. So that is going to be the default, and in case it is not the default, still you break out of that default. Ever after break, you terminate. Yes, you jump out of that. Then remember a switch. A switch, it is a block of statement. And remember, blocks are put always in that parenthesis. So whatever we have here is supposed to be inside that parenthesis. It starts from here and it goes all the way where you end. Now it's the block of the switch is closed there. Now outside the block of the switch, we can output our grade. So the grade, the grades is scored is, so you want the scored grade. Okay, it is. Now we pick it from whatever is stored there. You put there grade, so it is going to allow us to display the grade, this one. Whatever grade is already stored in the variable grade is going to be outputted there. Then now we can end our program successively by supplying the word return 0. So the main will return 0 and pass over the control to the operating system. Now let's compile. Yeah. There was a problem here. This full colon is supposed to be put after each case. The full colon is put ever after each case. This was some mistake. Yes, supposed to be like that, not outside. Yep. So let us debug. I think I've debugged. Control S, then compile, which is F9. Yes, if there is no problem, yeah, compilation is done, then we can run. Enter students marks. Somebody gets 97. Score is A. Yes, you run again, maybe 64. Score is D. Yes, you run again, the program on C. 54. Score is E because 54 is within 50. 54 divided by 10, it gives you 5.4, which returns 5. Because the case of 5, it gives a score of, it gives a grade of E. What happens when we get like a 25? That is now a default. Anything which is beyond, which is not within our case, it is a default. But what if you enter mark like accidentally you enter negative 50? The score is still F, which is not the best, it's not correct. What we can do, we can add other cases besides the default. Okay? We can add other cases which are going to describe all the situations, and then we make the default for any other mark which does not evaluate to any of these cases. It it will get some other grade, and that will be maybe grade X. For any mark which is meaningless, it should be grade X. So let's say case 4, also case 3, and case 2, that means anybody who gets 20s, and case 1, yes, and case 0, anybody who gets 0 point something, or 7 divided by 10 is 0.7, and that will evaluate to 0. So any of these, what should be done? This is too much indeed. What should be done should be given the grade of F. That should get the grade of F, and then you break out of that. Terminate, save, F11, that is compile and run. Enter marks, somebody gets 20, the grade is F. Compile and run, this is just now run, F10, somebody gets 4, the grade is F. Enter, run again, somebody gets 200, the grade is X, because 200 divided by 10 gives you 20, and you don't have case 20. So anybody who gets any of those, you make a mistake accidental and you enter 110, that grade is going to be X, because it is not meaningful. Or instead of even saying grade, we can ignore this and then just say, maybe you just write this statement: C out you have entered an incorrect mark. Yes, it can also be like that. You have entered an incorrect mark. After that, jump to new line. Yes, save, F11, compile and run. Yes, you enter 130. You have entered an incorrect mark. The grade scored is, you can see there is no grade which has been assigned. Okay. There is no grade which is assigned because 130 does not match any of the cases. It does not match any of the cases, so it is not given any grade. That's why I said the grade scored is, because that statement is executed always irrespective of whether it is assigned a grade or not, because it is outside the scope of the switch statement. So that is how we use the switch instead of the else if statement. Yes, so if please you have enjoyed, don't forget to subscribe and then share. Hit the bell always to be the first person to know in case a new video has been added. And do not forget also to share. Sharing is good. Have a nice time and bye bye.